Welcome to Thrashing Code. I'm Adrian, your host here on the channel, and today I'm going to get into a new programming challenge utilizing C#. I think I'm going to do that one or two more times. In the very near future, I'm going to dive into some Go, Python, and other languages that my polyglot self, utilize to get the job done on a day-to-day basis and do these fun little programming exercises. So this one is... I've started writing the blog entry because I've always start writing the blog entry. Then I'm like, okay, I do the video and then I finish the blog entry, etc. And I like to complement each other with video and with the blog post. So you have it in both formats so you can choose which way to kind of dive into it. And they're slightly different, but same programming problems. So if you've watched any of the previous ones, this one will be just like that in that format. This is conquering the top words challenge, and I'm doing it in C# again, and I'm going to use probably some regular expressions and some link magic on this one, because it's like, how else do you pick the top words, right? That's the kind of stuff you use, unless you're using some magic AI stuff or something. But anyway, we're not going to use AI this time for the coding. However, after I go through and solve the problem and then refactor it, because I always like to refactor it after I've kind of just banged through it, I will, of course, have a follow-up video where I will solve the same problem with AI and do it in a matter of seconds, because AI is replacing all our jobs. Anyway, it's not really replacing any jobs at all. What it's doing is making all of us vastly quicker and more efficient at getting the jobs done. So, with that, let's get into the top words challenge. All right, so here we are with the project. The way I've set this up is a little different than the way I've been doing it previously, where I just opened a folder and then added the projects to it, where there wasn't really a solution file. Kind of a different way. Well, if you know .NET or if you worked with it for a while, you know that's kind of like a different way to do it. That's not super common, but it's become much more common to do it that way. With this, however, I've taken the old approach and created a solution, which has a solution file, and then added projects to it. So the solution is top words. Then I have a top words class library and a top word test library. So same thing as I've done with the other projects, but just slightly different in how I set up the project/solutions structure and everything. So it's a .NET thing. If you're not familiar with it, it doesn't really make that much difference. Like if you're gonna take this, use this as something to learn from, and then go to another language. Like you don't have to have a bunch of weird structure to it or whatever. Now the problem, what is the problem that I'm going to work on? Okay, so this is the top words thing. So the code challenge works like this, right? Imagine you have a string of text filled with words, punctuations, and all that kind of stuff, right? You know, you gotta, like the cat and the dog ran up the house to the trees of on the hill, whatever, you know, like that's a sentence. And then you'd have a story about Tom Sawyer and Huck Finn went to the Mississippi River to paint a fence, blah, 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 you know. So that's the idea there, is you have these sentence structures or paragraphs or whatever text. It could be lorem ipsum, right? And what you want to do is basically is to write a function that's going to return an array of the top 3 most frequently occurring words in descending order. So pretty simple, right? So top 3 words, you know, not obviously words don't include commas and separators and all that other stuff. That's for the sentence structure itself, but just the words out of the structure, the top 3, and then in the descending order. So it'd be like 3, 2, 1, right? Or ascending, descending. Yeah, anyway. So that's how we're going to do it. That's the mission of this programming problem. And some of the assumptions are a word is a string of letters A to Z, optionally containing 1 or more apostrophes. So a word can have an apostrophe, like y'all. That has an apostrophe in it. And it is a word. It's in the dictionary now, so don't even get me started on that. And the apostrophes can appear at the beginning, the middle, wherever of the word. And then any other characters are not part of the word and should be treated as white space or dead space or whatever. So like if there's a pound, because it's a, you know, like a hashtag, we're not counting the hash. That's not part of a word. That's part of a hashtag. It's a different structure. The matches should be case sensitive. Okay, that might be a little tricky part. The words in the result should also be lowercased, however. So we'll do case sensitive checks to verify the words, because like let's say Smith. Smith is kind of a weird word. Not common that people use the Smith verb, but to Smith activities, you could say that, or you could call something the Smith. And that would be different words. So like Mr. Smith owned a Smith, right? Two different words. It's not the same word, so we need case sensitivity there. Ties may be broken arbitrarily. So if it's the same, we just push down or whatever. I don't know how we're going to do that. We'll just arbitrarily decide. And if the text contains fewer than 3 unique words, then either the top 2 or top 1 should be returned in the array accordingly. And just like empty array elements if there's no words in it. Like if it's just a sentence with a period or something weird like that. Like that's the string of text. So with that in mind, let's get some tests written to kind of formalize these arbitrary rules that I've just made up. Not that I've made up, that are part of the problem actually. And then we're gonna flesh those out. So, all right. So let's see. First, let's give the sample tests. That's the class one. Where's the test file? Give me the test file. There we go. All right. So the first thing we want to do is, I'll do what I always do: run and make sure it builds. Okay, project builds. That means we can start tearing stuff up. All right, test 1. Let's not call it test 1. Let's call it sample test. I don't know. I might I reserve the right to rename that at an appropriate time in the future when I have more of an idea of what it is it should be called. The first one, let's start with assert.that. We should name the class here. So top words will be the class. I'm gonna actually go with trio words dot top trio. Yeah, like that. And then we're gonna have an open close parens, and that's gonna be passed into that. So that's gonna be our method that we eventually write, and the class that the method is called off of. Top trio words will be the class, top trio will be the method, and then we're going to pass it something, and then we want to compare it to results, which will be is dot equal to, where's my equal, there it is, equal to, and we want to return an array. So let's do like new list, which is really a list, not really specifically an array, but whatever. List of that stuff with I don't know, what should we test for? We're gonna test. Let's just start with one that's gonna be letters, and the letters will be basically like words, right? So it'll be 1, and then 2, and then 3. There would be 3 of them. And over here, I want to actually go ahead and flesh this out. So let's create the type. We'll make that a class, and then go ahead and make it static, because that's a thing to do. And then we get the method built. Let's get the method built, put in here, and yeah, that looks mostly okay. String empty. So this will be our text body, our word, our messages. What should we call it? What should we call this? I'm kind of drawing a blank, but I want to name it something that's not just whatever. Like I don't want to do, okay, defaulting in. Let's just do S. It should be something like content or text content or word content or something like that, but I'm just going to go with S for now. And then we'll return no string for the moment. Oh, and we don't actually want to do that. We want to return an array. So let's do like, whoops. Empty trio of stuff, empty new list string, like that, and that'll be our return value for now. And that will enable us to come over here, static. This thing should be list string. That's what we're returning. So then what does this say? Use collection. Okay, sure, whatever, do that. Okay, so right now we're returning an empty string, which at least fleshes that out. And then let's go put that in our class here. Oops, what did it? Oh, did I? Oh yeah, okay, I have the class here already. So I go over here, do this, boom. All right, so now it's actually in our class project, so it's a reusable library. I can go back over here, and now when I hit the shortcut to do this, it will say reference the project, and that's what I want to do. So now the test references the project so it can test against the project. All right, so now let's get our first test in here. So I'm gonna go with something like A, B, C, C, D, 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 E, 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 E. Yeah. So that should give us 3, and the words would be A, D, E with E, D, A. It'll be E, D, A, the result theoretically. So let's go with E, D, A. So that's kind of a weird test, but this is an easy way to do it. It's all like single letter words, right? Words. If I wanted to verify if it was a word or not, I'd have to bring into play a dictionary, which could be tricky. Anyway, we're not going to do that right now. Maybe a later refactor, maybe with AI or something. So assert that, and then let's get a top trio of words, the top trio, and then let's go with E, and then DDD capital, DDD lowercase, and then DDD, and then we'll throw in some crap, and then, oh, what's wrong? Oh, I gotta put it in parens. There we go. Okay, and then let's go with D again. A. That should be 2 different. So then B, C, C, E. So that'll give us E, big DDD, and then no big little DDD, and then little BBBB. That's what that theoretically should be. So if I do that, and then say is dot equal to new list string, and here we can do 1, 3, and this needs to be a comma. All right, and then do I have too many parens in there? I think I probably do, so let's do that. All right, so that would be, oh yeah, so E, and then D, and then D. All right. Is that, wait. Yeah. I think based on our rules that should be it. Because I have 1, 2, and then I have 1 AA. That seems right. So let's write another assert. That, and then top trio words dot top trio, and then go through that is dot equal to, and then blah blah blah. Okay, now for this next one, let's see here, what should we, oh, now is it going to let me add argument actual? No. How am I missing? Let's see here, there's this one, and then this one, and then that one, and then semicolon. What in the world? Why is it expected? Expected here? Here? What is happening? What is going on? What? String. Oh crap! This is not needed here. And then this needs to go up here. So two. Okay. There we go. Matched parens. That was some trickiness. All right. So let's go with something like won't. No, it's so that should give me won't and won't. Well, let's put a space in there so we can test out for that. And then so we should get won't and then won't. And that should be it. Why is it fussing now? Oh, because I didn't put braces in there. Programming is hard, y'all. Now what am I doing wrong? Oh, because I didn't do a list either. I got way ahead of myself on this one. Let's do new list string. We'll put them in there. Oh God Almighty! And then we got another too many parens. But then okay, what? Oh, because it puts it there, and I don't actually need that one. So that's a problem with like autocomplete conflicting with like anyway, whatever. Okay, that's enough tests for the moment. Let's write some implementation code. Okay, I got this. Obviously, that's not gonna work. So first thing first, let's get a cleaned up list of the words, and we'll start with a regex. Replace the stuff out of the string with the regex piece like that, and we'll replace all the fancy character stuff with just a well, let's do white space, because then that'll be pretty easy to exclude. And then here we want to use A to Z. Oh wait, we need to do a word, a regex word, a regex match, I think is what that is called. You put it in the brackets like that, and then caret A to Z, and then A to Z. Oops, Z. So uppercase, lowercase letters, and include little commas in there, or apostrophes for like y'all and things like that. Okay, so that should give us the cleaned up text. What is this saying? I don't know what that means. I'll go back to that. All right, so then we want to do words. We'll take the cleaned up text, and we're gonna actually go. I'm just gonna go with two lower to start with, because I think I've opened up a can of worms if I start to try to do casing and everything. So let's just do two lower, then split on basically any white space, right? Oops, white space like that. And then what is it bitching about? I have more problem with parens lately. Parens. So I did two lower and then split. Open, close, parens. Oh, and then I need to go in here, right? And then do a remove empty entries. Okay, that got it. But wait, there's more. Well, okay, I'm gonna write more before I start. Or is there? What is this saying? I put that in parentheses. Gah! Parentheses are kicking my butt lately. So word counts equals new dictionary, and And then we'll go with a string and an int. Right, so yeah. So then I can keep count and the word and then the count of the word. Yeah, okay. So then we're going to loop. Let's loop through that result. Did you just get super carried away thing here? So this is going to be words. And I want to do the word in the words. Or take action on the word in the words. And if string that is null or empty. Wait, I probably want null or white space. Null or white space. If that's true in the word. Or if regex matches on word. And then the junk. We want to exclude the apostrophe, but also other special characters. So that would be, I'm going to do caret and then look for apostrophes. So if there's just an apostrophe, that's not a word. Apostrophe has to be attached to letters in some way, form, or manner. And then other characters, not ampersand. There's the thing I wanted. Okay, did I parens too much again? Oh, if, yeah, if, and then do action. Okay. Oh, why am I? My braces are off. Make method return void. Oh, well, yeah, I just haven't got there yet. Okay, prevent distraction. I'm going to put this. Doop, doop. Okay, there. Now I won't see that until I get down there. So then, and then so if it's white space or it's any of the junk, just don't do anything. Continue. But if the word counts, let's try to add it. Word and then 1. Should I put it? Yeah, and then I can just do word counts. Come on. I'm having the worst time typing today. That, parens, and other braces and stuff. So add the word and then increment the counter. Right? I think that'll work. I probably broke something already. Okay, so anyway, and then the top words, word counts. All right, we're gonna use some link lambda action with the method chaining. So we're gonna do order. Yes, we're gonna order by descending. It's like it's read my mind. So then that would be on the value, right? The dictionary, there's the value, and then there's string and int. Yes. Yeah, we don't want to do it on the key. The key is going to be count, right? Well, anyway, okay, so the value, that's what we want to order by. The value will be the count. The key will be the word. Yeah. Okay. I don't know why that's. It must be. Is it late? I feel like it's late. It's Friday. It's late Friday. I'm being an Uber dork here and doing this. So then the key, that'll be the word. And then I want to take only 3 to do that with. And then I want to have 3 in the selected final list. Not plus x dot key, that's the words. And then I'm going to turn it into a list like that. And it's going to be beautiful because then I can do oh, it's all grayed out. It's messing me out. Return. What? Can I not do? What am I messing up? So top words is, if I just return 2 words like that. Oh, and then is it because I have a, oh, I actually have a string array up there. No. Let's do, no, I want to undo that. There we go. And then change type method. Yeah, change to return a string instead of an array. So we're going to do a list string return instead of an array return. I know previously I said array return, but we're going to do a list return. Yeah, because it's just easier that way. So we get the clean text, then we get the words, then we get the word counts by going through the word in the words, and we count all the word in the words and increment, excluding the special characters and other stuff that might still be in there. And then we take the top words from where we get the top words from the word counts, order it by descending, by the order by descending, the value, then the key. So that puts it in order of the numbers and then the names. And then we pick the 3 to put in the select to dump into the list. Yeah. And then we return the top words. And yep, that should do it. All right, tests. Help me out here. Are we going to succeed? DDDAA. DDD. AA. 1AA. Oh, wait. Okay. I wrote this in the mindset we're going to do it by case. It's case sensitive stuff. But I just dumped it all to the lower. We're not doing case sensitive, so uppercase DDD is the same thing as lowercase DDD because everything goes lowercase once it gets checked. So that would make DDDD. So we go to E and then DDDD and then AA because we'd have 3 AAs and then AB and then CC. So yeah, 3 AAs. So this should be AA. Oh yeah, it looks like it was working. Yep. Okay. So then that should pass. Hey, there we go. Yep, programmer life. All right, so we got all that. And that's kind of a lot. 36 lines of code, including all the the skeletal stuff of C#. What can we do to clean this up? What does this do? I'm going to convert to generate regex attribute. What? I don't know, bud. I don't know if that one's, yeah, I don't know. Okay, how's it look before? So I have it replacing. Any, not letters with white space. And then, okay. So basically that, I don't know. I don't like that. I didn't like that. So I'm not going to mess with it that way at this point. But let's see. I feel like we have a ton being done right here with this link statement. And I feel like also I should be able to do this, return that, and get rid of that. Okay, so that's one line. We'll get rid of the return statement. So then, I start with a regex. What if I do the regex and then I start to link the link lambda functions off of it? I don't know. It seems like that would be possible. So like if I did, so I select and then if I went, yeah, if we did like a regex dot matches s, right? Yeah, okay. And then we just did like A to Z these things, but we like to lower. I think that, okay, that should work. That should make it to lower before it sticks it in there. And then, so any words there. So that's kind of like I'm doing the opposite. I'm just picking out the words instead of putting in white space to, and ignoring the words to give me the clean text. So that should be clean text right there. And let's do this. Let's return like this. So and then if I what do I do? Let's do select. Whoops, select. There we go. Let's do the match. So the matched value. Yeah. So if I select the values where the word is not like the single apostrophe. Basically, I need to do the opposite reverse of the thing above. Like basically the white space or is matched. So I need to do see, where's my caret? There's my caret. The apostrophe and the special characters and or any, yeah, I think that's it, right? So yeah, it would just be the same thing. So if, and I'm gonna remove the white space. Did I remove the white space? I might be doing this backwards, but anyway. Okay, so that's the where is match on that, and then group by the word and do it descending, which would be word dot the count. But that, oh yeah, so that would be a group. Let's do grouping instead of word. Grouping. Yeah, and then I think we need to do the grouping so that the grouping is by key, and then we need to take. This hurts. I haven't done this in so long. I don't remember what the hell I'm doing. So I need to take 3 because I'm doing basically what this is now. So then I would do select, and we get the select by the key, which would be the word. So the 3 words, and that comes along with the count. So and then to list. Right? I think that covers all the above. So that can just be dead. And I think I can kill this. What is this? What, that doesn't have anything to do with the staticness of the method? What? Okay, that's weird. Hold on. I'm just going to comment this. I'm going to... I did save it, right? Let me... Give me a second there. And I'm going to pause. Whoops. I'm going to pause it. Okay, basically I committed that last one to my repo so that I would have that before and then this after. So when I write up the blog entry, it meshes with the before and after the refactor here. So this is my refactor. Oh, and I haven't even run the test yet, so you get to run the test with me right now. So basically what we have is I just refactored it to just the regex and calling the link methods on the regex. So let's see, go back to the test and we're going to run it and we get, yeah, success. Okay, that rocked. So another little video magic here. And I have added some of the tests from like the original sample test project or whatever I got off the web. Because I think I got this from like Code Wars or something like that, and it had like some of these sample tests for it that you needed to meet or whatever. So I added those along with my other ones, and I think this should cover all the bases. Like this is no word, just empty string, empty list, empty list, empty list. And of course I went to list instead of array because it's just better to do it with this than the array. I guess I could return an array, but whatever. This is cleaner. So if we go back over here to the code and then if we just run it, yep, success. So this meets the other like outer external criteria and everything. And this little bit of code, this little regex with the link statements attached like that to select the 3 descending words by count. Yeah, there we go. That's what that does. And we've narrowed it down to just a mere 19 lines of code from like I think 30 something before. So we've almost halved it. That's pretty good. That's a nice shaving code. If of course you're cool with link statements and doing it like this. There are some anti-patterns out there that say, chaining this many methods off of something, the link or whatever, would be an anti-pattern, right? Because it's quote unquote hard to read. But in these cases, it kind of looks like a select statement, not like a SQL select statement in a way. Like it sort of makes sense to me in that sense. So even though it kind of conflicts with general C# code, or if you're used to looking at certain other things, it works out. Like you can get used to it. You just got to give yourself some time. And you end up with like clean little sections of code like this instead of the blurb that I wrote in the first place. But this and the other bit do execute and successfully execute all those tests and perform the function that we set out to do. So with that, I'm going to bid you adieu with this particular code problem. And on the next one, we're going to do a little refactoring, but it's going to be all AI. So we'll see what we come up with then. Maybe it'll come up with this. Maybe it'll come up with another way to do it altogether. I don't know. But we will find out shortly. So join me in the next video, which I will link here wherever I do. And in the meantime, happy thrashing code. Cheerio.